Greetings to all. This session is for 9th standard, chapter 1, number system, exercise 1.3, question number 5. What can the maximum number of digits be in repeating blocks of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. If you look at the number, it is 1 by 17. In the denominator, you can see 17. So, number of digit repeating is n minus 1. That is, 17 minus 1 is 16 numbers will be repeating. See, since we have to perform a division, let us perform the division by dividing 1 by 17. In order to perform the division, you should know the tables of 17. I have written the tables to make the process easy. 1 is not divisible by 17. Now you have to put 0 point. Then take 0 here, it will be 10. Even though it is not divisible, add one more 0 to the quotient and take one more 0 here. Then it is 100. 17 5s are 85, 17 6 are 102. So 17 5s are 85. Next subtract, you will get 15. 15 is not divisible, so add 0 to it, then it will be 150. 17 8s are 136. Subtract it, you will get 14. Then add 0. Again you start dividing. 17 8s are 136 again. Subtract it, you will get 4 and here 0. Then add 0, it will be 40. Then 17 2s are 34. When you subtract, you will get 6. Take 0 again. 17 3s are 51. When you subtract it, you will get 9. Put 0, then it will be 90. 17 5s are 85. When you subtract it, you will get 5 and take 0. It is 50. Again 17 2s are 34. Subtract it, you will get 16 as a remainder. Take 0. Then 17 9s are 153. When you subtract, you will get 7 0 here. Then take 0, it is 70. Then 17 4s are 68. 17 4s are 68. When you subtract, you will get 2 as a reminder. Put 0, then 17 1s are 17. Subtract, you will get as a reminder. Take 0, then it is 30. Again 17 1s are 17. When you subtract, you will get 13 as a reminder. Take 0, then 17 7s are 119. 17 7s are 119. Then if you subtract, you will get 11 as a reminder. Then the process will continue again. Take 0. Then 17 6s are 102. 17 6s are 102. Subtract it, you will get 8 as a reminder and 0 here. Put 0, it is 80. 17 4s are 68. 68. When you subtract, you'll get 12. As a reminder, put 0, then 17 sevens are 119. When you subtract, you are left with 1. See, again the process will start from here. Now, quotient obtained is 0.0588235294117647. When you count it, you will get 16 number. Let us check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See, we got the same digits. Hence, this is a process and you have to conclude. You can conclude by writing there are 16 digits in the repeating blocks of digits in the decimal expansion of 1 by 17. The meaning is when you divide 1 by 17 in the quotient, you will get 16 numbers and it will be these 16 numbers will again repeat. Question number 6. Look at the several examples of rational numbers in the form of p by q, where p and q are integers with no common factor other than 1 and having terminating decimal representation, that is expansion. Can you guess what are the property of q must be satisfied? Here you should understand the question before answering. You have to take the rational numbers which are in the form of p by q and there is a condition. The condition is with no common factor. There should not be a common factor for both p and q other than 1. You can take any examples and you have to test for the property of q. Here I have taken 1 by 2 as an example. For example, 6 by 2 cannot be possible. Since though it is in the form of p by q, it is not possible to take because both are having the common factor. Hence 6 by 2 is not possible and even 6 by 3 is also not possible. Here you have to follow the condition, that is they should not have common factor other than 1. Hence I have taken 1 by 2 and 7 by 8 and also 1 by 5 and so on. Let us see how it behaves. Take 1 by 2 and divide. 1 by 2, it is not possible. I have taken 0 point and it will be 10 then. 2 5s are 10. It is 0.5. When you divide 1 by 2, you will get 0.5 as a quotient. Here q is 2. Q can be written as 2 to the power of 1. Similarly, if I take 7 by 8, the numbers are in p by q form. Divide, you will get the quotient as 0.875. When you observe 8, 8 can be written as 2 to the power of 3. Here I have found the factors. When you divide, you will get 2 to the power of 3. I have taken 1 by 5. One more example. The quotient got is 0.2 and if you observe q, q can be written as 5 to the power of 1. Same way, when you observe the example like 3 by 25, the quotient is 0.12, but when you observe q, the q can be written as 5 square or 5 to the power of 2. 25 can be written as 25, 5 5s are 25, again 5 1s are 5. Go for next example, that is 9 by 20, which has no common factor other than 1. When you divide, you will get 0.45 as a quotient. If you observe 20, this 20 can be written as 20, 2 10s are 20, again 2 5s are 10, again 5 1s are. When you observe, you will get 2 to the power of 2 and 5 to the power of 1. And we can take one more example, that is 329 by 400. When you divide, you will get the quotient as 0.8225. Here, when you look at the cube, it is 400. When you express 400 in terms of prime factor, it is 2 to the power of 4 and 5 to the power of 2. 200 2s are 400. 200 2s are 200. 250s are 100. 225s are 50. 5 5s are 25. When you express this 400, you can write it as 2 to the power of 4 and 5 to the power of 2. When you look at all these, all cube, it is either the power of 2 or it is either the power of 5. Sometimes it is a combination of 2 and 5. So you can conclude, see, they are asked the question, what property the cube must satisfy? If you observe all these properties, you will come across the common property, that is, the cube is always the power of 2 or power of 5 or sometimes the power of both 2 and 5.
If you find these videos are useful, please don't forget to subscribe.